Next, which one you want? The given force. R is not known, we are not interested in this, right? So we have to take the given force. The given force is 4g divided by sine of opposite angle. Which angle is that? This angle, right?
Yes.
So what is that angle? That's 90
That
plus.
angle will be 90 plus 40.
Fine.
Yes.
So I think these two values will be same, correct?
Yes.
Those two values will be same, and we will end up with P equals 4g, correct?
Yes.
That's it. So it's a very small problem. Let's see what we have next. 10th one is over now.
Yes.
Next we have to go for 11th one. Let's take the 11th one. Okay. Okay, so we have a particle of mass 2 kgs. So here A is the particle of mass 2 kgs, right?
Yes.
And this will be 2g newtons. In equilibrium, F is the force which is pulling it downwards. Okay, the plane makes an angle theta, and theta is given as tan theta equals 3 by 4, right?
Yes.
So if tan theta is 3 by 4, what will be sin theta?
Sin theta will be.
So this is theta. So 3 and 4, using Pythagorean's relations, we get this as 5 now.
Yes.
So sine of theta will be 3 by 5.
Yes.
Cos of theta will be 4 by 5, correct?
Yes.
So these we need to make use. Then particle is attached to one end of the light inextensible string which passes over the smooth pulley as shown. The other end of the string is attached to particle B. B is having mass how much? 5 kgs.
B is. Yes.
And particle A is also acted upon by force of magnitude F. Okay. So what are we supposed to find? I think the part of question is on the next page. Okay.
Yes.
So this is all we have to find. Okay. So this is all we should to find. So first we have to find the magnitude of normal reaction. We have to find the magnitude of normal reaction. Reaction means we'll get a force here, right?
Yes.
So this, let us call it as reaction R. We have to find this reaction in the first bit. Then we have to find the value of R. Then state how you have used the fact that the pulley is smooth in your calculations. Okay. So, all right. So in such cases, I had told you that we'll be taking this axis as y-axis, no?
Yes.
And this line as x-axis, right? So we have x-axis and we have y-axis. So this angle here is same as theta. So now this is downwards. So if you take free body diagram of this part, downward 5g, upward is tension, है ना? So
Yes.
downward and upward both will be equal. So tension will also be 5g. Now this is a smooth pulley, and both sides of the smooth pulley we will have same tension now. If tension is T
Yes.
in this side, that side will also be tension T. Now we need to take free body diagram of this part. Okay. So let's take free body diagram of this ball over here. Okay.
Yes.
So this free body diagram we need to take. Now here this angle is theta. This is backside force T. T is how much? 5g na. T
Yes.
is 5g, and the downward force is 2g, correct?
Yes.
Reaction we need to find. A is the point and the F is the force on this side. So first we need to find R. How to find R? For R we need to take sigma y equal to 0, है ना?
Yes.
forces in y direction. So how many forces are in y direction? We have r that is acting upwards, minus, because component of this will act downwards. What is that component?
Yes.
2g
2G.
times sine या cos, because it
Uh,
is inclined to y
2G.
axis. Yeah,
2G times cos.
cos. So 2g cos theta. So total should be 0, no?
Yes.
So we know the value of cos theta from this diagram. It is 4 by 5. है ना?
Yes.
So substitute that, we will get r value as minus becomes plus on the other side into 4 by 5. So what do we get? Calculate.
Yes.
2 times 9.81 by 5 into 4. That is, we got,
15.696.
it should be into 15.696, so 15.7. Okay, 15.7 newtons. That is the value of r. So a bit is clear, a bit is solved. Next, what is he asking? He is asking the value of f. He is asking the value of f. Okay, so for f, what we need to do? We have to take sigma x equal to 0. Now how many forces are acting in x direction? T is acting in positive x direction, so let's take T. Then f is acting opposite, so minus f. And component of 2g, which component? 2g sine या cos? X component of 2g is 2g sine theta, correct? Hello?
Yes, sir.
Yeah, and it is acting in which direction? Opposite to x now. So that should be
Yes.
minus. So we have considered all the forces, total should be 0. So sine theta value from here we know it is 3 by 5. So substitute that, and t value we know t value is how much? 5g.
Yes.
F is the only unknown. So f equals 5g minus 2g into 3 by 5. What do we get? Five into 9.81 minus 2 into 9.81 into 3 by 5. 37.28
Yes.
newtons. So B bit is also solved. Then
Yes.
C bit is asking how did you use the information that the pulley is smooth? How did we use it?
No friction.
No. He's asking
No
about
tension.
pulley. Tension is same on both sides, no?
Yes.
Tension is same on both sides if pulley is smooth. Of smooth pulley, you can say. Of smooth
Yes.
pulley. That is the answer. Then next, let's go back to a question, see what we have next. So 12th question. So the 12th question is here. Take a new page. So particle of weight 20 newtons. So this particle is having 20 newtons weight. So let me show it downwards because space is there here. 20 newtons is the weight. On a smooth pulley, it is maintained by equilibrium by two forces as shown. One of the forces is horizontal, 5 newtons. Other is P newtons, that is acting at 30 degrees here. Find the magnitude of normal reaction between the particle and plane. Okay. So instead of showing that downwards, can I show it upwards, the reaction? Can I show the reaction upwards?
Yes, sir.
Instead of showing the reaction downwards, can I show it upwards? Yes, I can show, and that law is called law of transmissibility. Okay.
Okay, sir.
Transmissibility says that if you push or pull with the same force in same direction, the result is same. Okay.
Yes.
So instead of pushing from this direction, I'm pulling it from this direction. So this is the reaction, normal reaction. Then again we have to take x and y axis. So this is our y axis, and this here is x axis. Okay.
Yes.
Okay, x axis and y axis. Then this one is horizontal, this is okay. So what is this angle? Angle will be same as this.
45 degrees.
Yeah, 45 degrees. And for horizontal, this angle will be 45 degrees, right?
Yes.
And this is 30 degrees from horizontal. So what have we been asked? It is maintained in equilibrium by application of forces. Okay. As shown, find the magnitude of normal reaction. So we have to find R, है ना?
Yes.
R is the only value he is asking, or is he asking P as well? P is not asking, but P also we have to find if you want to find R. Okay.
Yes.
So first we have to take sigma x or sigma y. Should we take x or y? R is perpendicular now. R is along y direction. And P is also inclined. So if you take sigma y first, you will get two unknowns. Okay. So it's better to go with x. So first let us go with sigma x. So what are the forces in x direction? We have x component of P, that is P cos 30. Correct? And then 5 is acting opposite, so minus 5 cos 45 now. Correct?
Yes.
What is the component of 20 newtons? X component of 20
newtons cos 45.
No, sine this side nama.
So we're taking yeah.
So 20 sine 45, is it positive or negative? So the two components will be like this. First is this, the other is this, right?
Yes.
So it is going up opposite of x now.
Yes.
So that is to be minus, right?
Yes.
So let me take the same. Then have we considered all the forces? R will not come in this because it is perpendicular, right? So total should be 0. P is the only unknown, find it. So P equals how much? Shall we do directly the calculator? Okay. So both the terms are negative, send it to the other side. So 3 cos 5 cos 45 plus 20 sine 45 whole divided by cos 30, correct?
Yes.
So 20.41 newtons. So we got the value of P now. Now by using the value of B we can get R. Now we have to do sigma y. So if you take sigma y, R is in positive y direction. Then components of all three forces we have to take in y direction. So one by one let's take.
Yes.
What is the y component of P?
Y component of
This component, no?
Yes.
We are going opposite, right?
So it will be sine.
Yes. So P sine 30. Positive or negative?
It will be positive.
Positive, good. And then what is the y component of 5 newtons? 5 into this component. Again we are going away now. So what do we get? 5 sine 45.
Yes, sir.
5 sine 45, correct? Component of 5 Newton. Y component
Yes,
of
sir.
5 Newton is 5 sine 45. And is it positive or negative?
Positive.
Positive, because it is upwards. Then we need component of 20. What is the component of 20? Y component of 20 is 20.
My
This
component of 20 is
sine or cos?
20 cos 45.
Yeah, cos 45. Positive or negative?
That will be negative.
Negative. So this total should be 0. So now here there is only one unknown, that is r, है ना?
Yes.
So find the value of r. So let's take all these values to the other side. So p minus 20.41 by 2, because sine 30 is 1 by 2. Then this becomes minus 5 into sine 45. Then this becomes plus 20 into cos 45. Correct?
Yes.
So we're getting 0.40. Correct?
Yes.
So very less reaction, because both the forces are lifting the object upwards. Okay,
Yes.
so that is reducing the reaction. Clear? Any doubts here?
No, sir.
Okay, let's go back and check what's the next question. Then we have friction and static particles. So law of friction I have explained to you, not last class.
Yes.
Okay, so we need to go ahead and use the law of friction to find this. We had done this, isn't it?
Think so.
I think we were doing one of these problems when the power went out.
I think so, sir.
Yeah, fine. So shall we go directly for exercise?
Okay, sir.
Okay, so let's come here. So this. Right. Okay. So we have a book of mass 2 kg resting on a rough horizontal table. Okay. So we have a rough horizontal table on which a book is placed. Let us say this is a book, and let's say this is the surface. Okay. So mass of the book is how much? Mass of the book is 2 kg, right?
Yes.
When a force of magnitude 8 Newton is applied on the book at an angle 20 degrees to horizontal in upward direction. So we are applying a force like this, right? At 20 degrees we are applying a force of 8 newtons.
Yes.
The book is on the point of slipping. What is the point of slipping? Point of slipping means the friction is highest at that point. You know,
Yes.
friction is highest at that point. So normal reaction, let's call it as R. Friction will be acting backwards, right?
Yes.
So friction, if it is equal to maximum friction, that means it will be mu times R, no?
Yes.
And what is he asking us to find? Calculate to 3 significant figures coefficient of friction. So coefficient of friction he wants us to find. Okay.
Yes.
So here again we can go with sigma x and sigma v, right? So this
Yes.
will become our x-axis and this will become our y-axis. Okay. So which one you want to go first? Y.
Okay, sir.
So y, R is acting upwards. 2 kg. Kg means 2g, na?
Yes.
So what is G?
G is 9.8.
9.81. That is acceleration. Then component of 8. What is y component of 8? 8 into sine 20, correct?
Yes.
And it is acting upwards, so positive. That's all. This total should be 0. So we get reaction as 2g minus 8 sine 20. Find it. So 2 into 9.81 minus 8 into sine 20. 16.88. Correct?
Yes.
So now once we know this, we can go with sigma x. So 8 cos 20, that is in forward direction, minus mu times r. These are the only horizontal components. So total should be 0. So here r, we know the value of r now. So substitute the
Yes.
value of r, we will get the value of mu. So 8 cos 20 divided by r. R is 16.88. So this is the value of mu. Find it. What do we get? 8 times cos 20 divided by 16.88. 0.445 now, because he is asking
Yes.
3 significant digits. Okay,
Yes.
because he is asking 3 significant figures, we have to take 3 figures. Then that is the friction. That's it. Let's go back, see what's the next question. Okay, so we have a block here. Okay, let's come back. Okay, okay, a block of mass 4 kg rests on a rough horizontal table, and a force of 6 Newton acts on the block at an angle 30 degrees to horizontal in downward direction. The block is at the point of slipping. I think this one also we have done. So again, let's say block, let's give it a rough rectangular shape. This is the rough horizontal surface. Then what is that? The forces on this, forces, downward forces, how much? 4g should be downward force, and a force of 6 newtons acts on the block at an angle 30 degrees to horizontal in downward direction. Downward direction means from here we need to take here in downward direction. The angle here is 30 degrees. Okay, the block is at the point of slipping. Find the value of coefficient of friction. Once again we have to take all the forces. So we have upward force. What is this? This is the reaction. Then because the force is pushing it right side, friction will act on the left side, right? And this is mu times r, correct?
Yes.
So start solving now. So which one you want to take again? Shall we start with vertical again? So this force is value is given now 6 newtons.
Yes.
Okay, so sigma y again. So this is our y-axis and this is our x-axis, right? So sigma y, all the forces in y direction. R is upwards, minus 4g, and the component of this will also act downward, right? So
Yes.
6 into sine or cos, vertical component. Sine or cos?
For this one, the vertical component will be sine.
Sine, because it's going away, you have to take sine. So sine of 30, positive or negative?
It will be negative.
Negative. So r and that. So all the vertical components taken. So sum should be equal to 0. Of r is the only unknown here. Find it. So r is 4g plus 6 into sine 30. Sine 30 is 1 by 2. So that is 3. So 4g plus 3. What do we get?
Jeez.
42.24
Yes.
newtons. So now we know the value of r. Next we have to take sigma x. What are the components in x direction? 6 newtons. What is the horizontal component? 6 into cos or sine?
Horizontal component is 6 into sine.
Sorry,
Cos.
cos. Because this is adjacent now. Adjacent
Yes.
means we will get cos. So 6 cos 30, and it is acting in which direction? It's acting in forward direction. So this is to be positive. Correct?
Yes.
And this is acting left side, so minus mu r. These are the only two horizontal components. Total should be 0. Now here r value we know, so substitute. We will get mu as 6 cos 30 divided by r. What do we get? How much? Got it?
Yes. Yes.
0.123.
Yes.
Next we have again a block of mass 2 kgs. So third one we have to do, no? Next. Block of weight 10 Newton rests on a horizontal surface. A force of magnitude 3 newtons acts on the block at 60 degrees above the horizontal. So let's again take a block. Okay. What are the forces acting? 10 newtons horizontal surface. Force of 3 newtons applied on the block at an angle 60 degrees above the horizontal in upward direction. Okay, so in upward direction, so at 60 degrees we are applying this force. The coefficient of friction between the block and surface is 0.3. So this force is 3 newtons. Weight downwards, how much? 10 newtons. Reaction will be here, R. Friction will be acting backside. So coefficient of friction is given, so directly we can write it as 0.3 times R.
Yes.
Now calculate force of friction. He wants us to find the force of friction. So this is the maximum friction, right?
Yes.
This is the maximum friction possible. So in this case we don't know whether friction is at maximum point or not, because nowhere he has said that the box is just about to start sliding, huh?
Yes.
So we have to keep this as unknown. So let us call it as FR. Okay, let us call it as FR. So now again take sigma V vertical components, R minus 10 and plus how much? 3 sine or cos, component of 3 newtons in vertical direction. What is it?
The component will be
Sine cos.
sine.
So sine 60. Okay.
Yes.
Right. So this total should be 0. So R should be 10 minus 3 sine 60. What do we get? 10 minus 3 sine 60. 7.40. Correct?
Yes.
And then sigma x. X is horizontal, y is vertical. So what do we get? 3 cos 60 is in forward direction minus friction force FR. Okay. If it is at limiting point, we can take it as 0.3 times R. But here we cannot take because he has not told it is in equilibrium. So these are the only two horizontal components. So FR will be how much? 1 by 2, that is 1.5. Correct?
Yes.
So friction force is 1.5. That means if we don't want the box to move, then 1.5 Newton force must be applied.
Yes.
In horizontal direction. Right, next, calculate force of friction. So FR we found it. This is the friction force. So this is the A bit. Okay.
Yes.
Then find whether or not friction is limiting. Is it limiting friction or not? For that, we need to find friction from the formula. What is the formula for friction? Mu times normal reaction, right?
Yes.
So mu, is it given? Mu is given as 0.3.
Yes.
So 0.3 times R, that is 7.4. Correct?
Yes.
So multiply them, you will get the answer. Getting? 2.22.
2.2.
So this is in newtons. So now compare these two and tell, is it at limiting friction? The friction required here is less than the limiting friction, no?
Yes.
So that means, is the object moving or stationary?
Moving.
No.
Stationary.
To start motion, 2.2 is required, but we are having only 1.5 now.
1.5. Yes.
So is it moving?
No, sir. No, sir.
No, it's not moving. To calculate friction force, we found it here. This is A bit. Then determine whether or not the body, the friction is limiting. The friction is less than limiting friction, no?
Yes.
Friction FR is less than limiting friction. Okay.
Yes.
Next. Which one is over just now? Third one is over now.
Yes.
So let's go for the fourth one. Okay, anyway. So packing crate of mass 4 kg. So there is a crate of 4 kg on the horizontal ground. It's filled with books that are evenly distributed throughout the crate. Coefficient of friction between the crate and ground is 0.3. Find the mass of the books if the crate is in limiting equilibrium under the effect of horizontal force 147. So let's start. Again we have a crate, so let's draw it as a crate. Okay. Then on top of this we have books. Coefficient of friction between the crate and the ground is, so mu is 0.3. Mass is 10 kgs, so mass, let's bring it down, 10 g, correct? So packing
Yes.
crate is 10 kgs. It is filled with books which are evenly distributed. Book mass of the books is not given now. So mass of books, let's call it as mb. If m, let's say m is the mass, so g will be multiplied. So m kg is the mass of books. Coefficient of friction between the ground is 0.3. Find the mass of the books with the creative and limiting the effect of. Okay, so if you apply, if you crate is in limiting equilibrium. So on the crate we are applying a force. How much? 147 newtons. So when we apply a force 147, it is coming under what is that? Equilibrium, limiting equilibrium. So that
Yes.
information we need to use. So let us say this is the normal reaction. This will be how much? How much, ma? Friction is this much, so 0.3 times r, because in this
Yes.
case he is telling that the object is in limiting equilibrium. No, limiting equilibrium
Yes.
means we have to take whatever friction is there here. So okay, that's it. Now find the mass of the books if the crate is in limiting equilibrium under the effect of, okay, so 147. So 147 newtons is bringing it in equilibrium. We have to find what? Mass of books. That means m we need to find. Okay.
Yes.
M we need to find. So ready? Let's go ahead and find m. So again we have to do vertical first, no? Sigma
Yes.
y, r is upwards, minus 10g and minus mg equals 0. So r equals 10 10 minus m times g, no?
Yes.
So r we found. Then sigma x, take all the horizontal components. So 147 minus 0.3 times r, correct?
Yes.
And that's all. So this total should be 0 again. So r equals 147 by 0.3.
Yes.
So r we found. What did he ask us to find? M, na? So 1 minute, sigma m, sigma r. So r is equal to this. So if you substitute r here, what do we get? Implies that 10 minus m times g equals 147 by 0.3. What do we get? We get the value of m as 147 by 0.3, and by G and 10 minus this, no?
Yes.
Because we have 10 minus m comes this side, so 10 minus 147 by, what do we get? Ten minus 147 by 0.3, so minus 39.95. How can it be
Yes.
minus? It shouldn't be minus. Something has gone wrong. Here both of them are negative, no? So it becomes plus on the other side. Okay,
Yes.
so plus here. So this goes on to become m equals 147 by 0.3 g minus 10. So what do we get? We get 39.95 positive.
Yes.
So this is in newtons. No, not in newtons. It is in kgs now. Because g also is divided. After dividing with g, we will get in kgs. Okay.
Yes.
So first bit clear.
Yes, sir.
And state whether modeling assumption, what modeling assumptions you have made. Okay. So what modeling assumptions have we made? He's already telling it is stationary. So normal reaction is normal to the surface. That is one assumption we made. And what other assumption? So this is the friction law, no? Mu into r
Yes.
is friction law, that is limiting friction. So that is another assumption we made. Okay,
Yes.
so this question is clear. Any doubt?
No.
Okay, fourth one is done. We have to go with fifth one. Block of 2 kg rest on horizontal plate. Force F is acting on the block 45 to horizontal. Limiting equilibrium is limiting. Mu is given. Okay, so find the magnitude of P for two conditions. Okay,
Yes.
so first condition, what is it? P acts downwards in direction, right?
Yes.
So if P is acting downward direction and direction, yeah, this force is downwards. Downward force is 2g, है ना?
Yes.
Downward force is 2g. This force is P. Then angle 45 degrees. Huh?
Yes.
So this angle is 45 degrees. Equilibrium is limiting. Mu value is given. Mu value is 0.3. Find the magnitude of P. Okay. So let's put all the forces, reaction force here. Because the object is moving right side, we have to take friction on the left side. Because he's
Yes.
telling, is it limiting friction? Equilibrium is limiting, है ना?
Yes.
So equilibrium is limiting means we have to take this as mu times r, correct?
Yes.
Mu is given as 0.3, so we can take it. Now again we have to go with the solution. So sigma x, sigma v, both are giving us equation in two variables, right? So we can start with any equation that we are comfortable with. So let's go with sigma y. R is upwards, minus 2g is downwards, minus p sine 45, correct?
Yes.
Downwards. Then r value, find it. 2g plus P value is given? No. So P, keep it as it is. So 2G is downwards, R is upwards. This is we have taken. So this is P sine 45 equal to 0, correct?
Yes.
Then let's take sigma x. What are the x components? P cos 45 now,
Yes.
and minus mu r now.
Yes.
So this is equal to 0. So let us put it in correct format. So mu r minus p cos 45 equal to 0. So now we have to solve these two equations. Which two equations? Equation 1, equation 2. Okay,
Yes.
give it 2 minutes.
Okay.
Hello, college. मित्र थोड़ा सा बोल. बघेन. नहीं, थोड़ा उशीर होता है आज. हाँ, so these two equations we need to solve.
Yes.
Yeah, so r value, let us substitute here. R, if you substitute, mu is 0.3 times r is 2g plus p sine 45, then minus this term, let's take it to the other side, we get p cos 45, correct?
Yes.
Now p is the only unknown here, we have to find it. 0.3 into 2g equals p, if we take common, we get cos 45 minus sine 45. Yeah? No. Minus 0.3 times sine 45, na?
Yes.
So find p. P will be 0.3 into 2 into 9.81 divided by cos 45 minus 0.3 into sine 45. 11.89 now.
Yes.
So p value we got it. Substitute this back in r. So we will get the value of r. What is the value of r? R will be 2g plus p. P is 11.89 times sine 45. So find it. 2 into 9.81 plus 11.89 into sine 45. 28.03, correct?
Yes.
Both are in newtons.
Yes.
So p value we found if it is acting downwards. Now the same problem we have to solve once again. This time instead of downwards we have to take it upwards. Okay.
Yes.
So let's take the same again. Now instead of p acting downwards, we have to take it acting upwards, right?
Yes.
Upward in this sense, we have to add it this side. So this is the force P. What is the angle? 45 degrees.
Yes.
Yep. So once again we have to solve it. So again we have to take sigma y. So sigma y. R is acting upwards, 2g is acting downwards. P sine 45 is acting upwards or downwards? Upwards. So plus. That's all. This total should be 0. Again R value we will get it as 2g minus p sine 45. Let us call this as equation 1. Then we have to take the next one, sigma x. So x components, what are the x components? P cos 45, no?
Yes.
P cos 45, and then minus mu r, correct? Should be 0.
Yes.
So once again there are two unknowns here, so let us substitute the value of r. Let us substitute the value of r here. What do we get? We get P cos 45 equals mu is 0.3 times r is 2g minus P sine 45. Once again take all the P terms on one side, we get cos 45, this is minus, so it becomes plus 0.3 times sine 45, correct? Equals, we get
Yes.
0.3 into 2g. So this time P is equal to how much? So everything remains the same except minus, we get plus. So 6.4 newtons. Okay.
Yes.
So look at the difference in P required. So here it is 11.89. Here it is 6.4. Almost double, na?
Yes.
So if you are pushing an object downwards, more force is required, and then when you are pulling it upwards. Okay.
Yes.
So if you are asked the reason, what will be the reason? Can you tell me the reason? Because friction will be more. If R is more, friction will be more, na?
Yes.
And when you are pushing it downwards, R will increase, right?
Yes.
But when you are pulling it upwards, R will decrease.
Yes.
So as R decreases, friction will also be less. Hence, the required force will also be less. Clear?
Yes.
So that is the explanation. This one is which problem was this? Fifth one is over, right? Next, we have to take sixth one. So a particle of mass 0.3 kg is on a rough plane which is inclined at 30 degrees. Particle is held at rest by a force of 3 newtons acting up the plane in the direction parallel this. Particle is on the point of slipping up the plane. What does it mean by up the plane?
Backwards, sir?
Up the plane means the object is about to slip upper side.
Yes, sir.
Okay. If you don't apply this force, what will happen? It will move downwards now.
Yes, sir.
So to stop it from moving, you have to apply upward force equal and opposite to the friction. Correct?
Yes.
When you apply force equal and opposite to friction, it will still be trying to slide downwards only, no?
Yes.
And then if you increase the force beyond the limiting friction, it will remain at rest till the friction becomes opposite. Initially friction was upwards. When you increase the force, slowly the friction starts changing its direction. Then the friction comes downwards. Getting
Yes.
it? So when the friction is equal to limiting friction, opposite to the motion, then it will tend to slide upwards. Correct? Are you getting?
Yes.
So now we have been told that it is sliding upwards. So friction will be acting in downward direction. There will be normal reaction. This is R. Friction value is given. Friction value, is it given? We have to find it.
No, sir.
We have to find the value of friction. So let's write it as mu R. Then there is a downward force. How much is downward force? 0.3 g, correct?
Yes.
0.3 g is acting downwards. So now we have to take this line, that line we have to take it as, this line we have to take it as y-axis. Then this line we need to take it as x-axis, right?
Yes.
What will be this angle? This angle will be 30 degrees.
Yes.
Yeah. So now let's take the components. So first y components, r is acting upwards. Which other components will get? 3 Newton is in x direction, mu r is also in x direction. So these two won't come in
Yes.
y components. Then this component of this, what is the component of that? 0.3 g sine or cos? So this is where you get confused every time. That's why I'm stopping at this point. Is it cos or sine?
Cos.
Cos, because it's adjacent. The cos of 30, and this is acting downwards or upwards?
Upwards.
Sorry? This is vertical, Namo.
Yes, sir.
So vertical means it is acting downwards, right?
Downwards. Yes.
So we have to take it as minus. That's all. Are there any other y components? No other y components.
No, sir.
So this total should be equal to 0. So here we get the value of r. R is 0.3 g cos 30. What do we get? 0.3 into 9.81. Yeah, 0.3 into 9.81 into cos 30. 2.55. Is it correct?
Yes.
G9 or the 10 or the 3 component. Yes, this is the value of r in newtons. Next we have to take x component. Okay, so what are the forces
Yes.
in x component, x direction? First we have 3 newtons, right?
Yes.
Then minus, so 3 minus mu times r, correct?
Yes.
Are there any other x components? 0.3 g, will it have a x component?
Yes.
So y component we have taken, x component will also be there now.
Yes.
So what will be the x component? 0.3 g sine or cos? This one is going opposite now.
Yes.
Opposite means sine or cos?
Cos.
It's sine now.
Sine.
0. This is the force. Force times sine 30 will give us the horizontal x component.
Yes, sir.
Is it positive or negative? Because this is acting downwards. So the component will also act left side.
Yes.
So left side means minus, correct?
Definitely. Yes.
So this total should be equal to 0. Correct?
Yes.
Now sine 30 is half, and here what? Here mu is the only unknown. You can find it. So 3 minus 0.3 g into sine 30 will remain the same side. Mu r, let's send it to the other side. So mu equals this total divided by r. Correct?
Yes.
R is 2.55. So find value of mu. So 3 minus 0.3 into 9.81 into sine 30 divided by 2.55. we are getting 0.6. Give me a minute.
Okay.
Hello. काय नंबर? हाँ, ठीक है. Okay. Okay. So clear? Any doubts here?
Yes. Yes.
Okay. So this is over. Next is this one, 7th one. So direction of friction, you need to be careful, okay?
Yes.
So if it is tending to slide downwards, friction will be upwards. If it is tending to move upwards, friction will be downwards. So let's take the next one. Okay. So next, what happened here? Yeah. So particle of mass 1.5 kgs is resting in equilibrium in the rough plane surface under the action of force x newtons. We don't know the value of x in upwards. Then the greatest slope of the plane, acting up the line of greatest slope of plane. The plane is inclined at 25 degrees to horizontal. Particle is in limiting equilibrium and on the point of moving up the plane. So once again it is moving upside. Okay. So where will the friction
Yes.
act? Friction will again act in downward direction, right?
Yes.
So this will be the normal reaction. Let's call it as R. Then okay, coefficient of friction is given, that is 0.25. Because he's telling it is in about to move, about to slide upwards, we can directly take it as mu times R. Friction is equal to mu times R. Then weight of the object is 1.5 g, correct?
Yes.
1.5 g it's given here. Then that's it, right? So we have been asked to find normal reaction on the plane. That means R we need to find. So here again, how should we do this? We should take this line as y-axis and then this line as x-axis. Okay.
Yes.
What will be this angle? What will be this angle? That angle will be 25 now.
Yes.
25 degrees. So now take all the forces one by one. So sigma y first. So upward force is R and downward force is how much? 1.5 g into sine or cos. This is adjacent, right?
Yes.
So adjacent means cos or sine. Adjacent means you should take cos. Okay.
Yes.
Opposite means we should take sine.
Sine.
So this is the simple logic which we need to remember. Okay.
Yes.
So because this is adjacent, we need to take cos of angle 25 degrees, correct?
Yes.
Are there any other y components?
No.
No. So total 0. So R equals, everything is known, substitute it, find it. So what do we get? 1.5 times 9.84, 9.81 times cos 25, 13.34 no?
Yes.
So R equals 13.34 newtons, right?
Yes.
Then sigma x. So what are the forces in x direction? So first we have x force in forward direction. So let's take x Then we have backward force. What is that friction force? 0.25 times R. Are there any other x components? Are there any other x
Um,
components?
no, sir.
Here, this is inclined now.
Oh, yes.
So you will get vertical and horizontal, both components for that, right?
Yes, sir.
So we are now finding horizontal. So my x component. X component, what will be x component? Now we are going opposite now.
Yes, sir.
Opposite means sine now.
Yes, sir.
1.5 g into sine of 25, correct?
Yes, sir.
And this is acting in positive or negative?
Um,
Opposite to x now.
yes, sir.
So because it is opposite to x, this should be minus. Okay, clear?
Yes, sir.
So that's the thing. So this total should be 0. When r value is known, we can substitute it here and find x. So 0.25 times 13.34 plus 1.5 g sine 25. So find it. Point 0.25 into 13.34 plus 1.5 into 9.81 to sine 25. 9.55. Correct?
Yes, sir.
Any doubts here?
No, sir.
X value we found. So B bit is also found. The first bit, A bit answer is here. B bit answer is here. Okay.
Yes.
Next. Okay. Eighth problem. Okay. So
Yes.
eighth problem. The horizontal force of 20 Newton is acting on a block. The weight of the block is given. How much is the weight of block? Weight of the block is 1.5 kgs, right?
Yes.
That means 1.5 g we have to take. G is 9.81. Now this is in equilibrium, resting on a rough plane inclined at 30 degrees to the horizontal. Line of action of the force is in the same vertical plane as the line of greatest slope. Okay, that means he is trying to tell us that all the forces are coplanar. Now
Yes.
A bit, he wants us to find normal reaction between the block and the plane. Okay.
Yes.
So has he told anything about friction? Last bit is about friction. Let's first find the normal reaction. Okay.
Yes.
So in order to find normal reaction, we have to take what direction? XY now.
Yes.
So this is our x direction and this is our y direction, right?
Yes.
So let's take that. Now what about angle? What is this angle? What is this angle?
It will be the same as
30
30
degrees.
degrees, I
Yeah,
see.
because we have two parallel lines to the two lines, right? We have this parallel to this and this parallel to this. So both the parallel lines will also have same angle. Then what about this angle?
Mm,
Once again, we have this perpendicular to this line perpendicular to this. So both the
yes, sir.
perpendiculars will again have same angle, right?
Yes, sir.
30 degrees, correct?
Yes.
So now again, so there are some more forces. Which other forces we have to take? We have to take normal reaction, right?
Yes.
So what is normal reaction? Let's write it as R, okay?
Yes.
So this is x-axis, this is y-axis. Now because we are interested in finding normal reaction, we have to take sigma y, na? So take sigma y, R is acting upwards. And what other components? Tell me one by one.
So 1.5 G
1.5 G
cos 30.
cos 30, good. Positive or negative?
Negative.
Negative, good. What else?
And then 20 sin 30.
20 sin 30. Positive or negative? Is it positive or negative?
I don't.
Think a little. You see the force is like this and we have two components in these directions, right? So because our force is coming towards a point, the components will also come towards a point now. Correct?
Yes.
Give me a minute.
Okay.
हेलो जी बोलिए. हाँ वो कल का सॉल्व हो गया, वो आ गया था, आ गया. थैंक यू. हाँ आ गया प्रोडक्ट आ गया. थैंक यू. थैंक यू. आ गया प्रोडक्ट. मैं तो रखता हूँ थोड़ा, मुझे मीटिंग. Okay. So
Yes.
is it positive or negative? Oh, because it is acting in this direction now.
Yes.
So downward means positive. Y is positive on the upper side because our force is acting downwards. So component is acting downwards. So we should take positive or negative. Negative, of
Positive.
course, because upwards is
Negative.
positive, downward is negative, right?
Yes.
So our force is acting towards negative direction, so it is negative. Okay.
Yes.
So these confusions, if you have any such confusions, you can please ask me. Okay. So
Okay.
practice this a little. Next class you should be able to answer the components. Okay. Because
Okay, sir.
in almost every problem we have to take the components, and if you are not good with this, if you get confused, instead of sine if you take cos, the whole problem will go wrong. Okay.
Yes.
So are there any other components in y direction? Even if you take friction, it will be in x direction, so we need not take it. Correct?
Yes.
So we have taken all three forces, so total should be 0. Now find the value of r. So all these terms we have to send to the other side and we get the value of r. So 1.5 into 9.81 plus into cos 30 now.
Yes.
Then this will also go on the right side, it becomes plus. So 20 times sine 30. So 22.74. Correct?
Yes.
So this is in newtons. So we found the value of reaction. So A bit is over.
Yes, sir.
So let us next go for which one. Next he is asking us to find magnitude and direction of the friction force acting on the block. So in which direction is the friction force acting? So we don't know which direction it is acting, right? So let us just call it as Fr. Let us call it as Fr, and let us assume it to be positive. forward direction. If we get negative answer, that means our assumption was wrong. Correct? Are you getting me?
Yes.
So let's take all the x components now. So now fr is in positive x direction. Then what are the other components? Okay, tell me the components of 20 newtons. X component of 20 newtons.
X component is cos 30.
Cos 30. So 20 cos 30. Is it positive or negative? This is going right side now. So
Yes.
component will also go right side now.
Yes.
Right side means positive x or negative x. Positive x now.
Yes.
So plus. Then component of 1.5g. X component of 1.5g. What do we get?
X component.
So that 1.5 is acting downwards. Again, you have components in this direction and this direction. So this angle is given as 30 degrees. So because our force is coming towards the point, the components will also come towards the point. Okay.
Yes.
So this force is 1.5g. So this side will be adjacent now.
Yes.
And what did I tell? Adjacent is? Adjacent is?
Adjacent is the same angle.
Cos. Whenever adjacent
Cos.
we get, we should take cos. And whenever we get opposite, we should take sine. Correct?
Yes.
So this is adjacent, so we should take cos. So 1.5g cos. Okay.
Yes.
But we want x component. So x component will be, we are coming in opposite.
Yes.
So 1.5g sine. Correct?
Yes.
So 1.5g into sine of 30. And is it positive or negative? This side, right side is positive, left side is negative.
Yes.
So is it negative or positive?
It will be positive.
Look at this arrow. It's coming left side, Nama.
Negative.
Yes. So it's taking very long for you to answer. A little bit of speed will be helpful.
The connection cut for a little bit.
Acha. It's a connection problem, then it's okay. Then have we taken all the forces?
Yes.
Yes. So here fr is the only unknown. Find it. So fr equals, so these both will become negative. So minus 20 cos 30 plus 1.5g sine 30. So let's go ahead and find it. Minus 20 cos 30 plus 1.5 into 9.81 into sine 30. So we are getting minus. So minus 9.96. So friction force is minus 9.96 newtons. Okay.
Yes.
So magnitude and direction of the friction. So magnitude is 9.96 newtons and it's acting in which direction? Negative x direction. Okay.
Yes.
So it's acting in negative x direction. And third bit, hence find the minimum value of coefficient of friction between the block and the plane. Okay.
Yes.
Minimum value. So friction is acting in downward direction. That means object is trying to slip upwards, है ना?
Yes.
Object is trying to slip upwards. So minimum friction should stop the object from moving upwards, correct?
Yes.
So that means this should be equal to the limiting friction. What is the formula for limiting friction? Mu into R now.
Yes.
So our friction Fr should be equal to Fl, and that is mu R. So that means mu R should be equal to 9.96. Substitute the value of R, you will get mu.
Yes.
So 9.96 divided by 22.74. Okay, find it. That is the answer.
Okay.
ट्यूशन है इतनी छोड़ा कॉलेज में 7 एक तो 7:30 वाजता ठीक ठीक है ओके did you get it?
Yes.
Okay, so how much did you get?
I got
0.44.
0.47.
0.437, so 0.44, we can round it off. So C bit is also done. Let's come back here. So 8th one is solved, 9th one we have to take up next. Let's go for the next page. Okay, ready?
Yes.
So box of mass 3 kgs lies on the rough surface like this. X is the force with which we are pushing it up. The line of action of the force is in same vertical plane. So that means all the forces are coplanar. Coefficient of friction is given here. Coefficient of friction is how much? 0.3. It's given here. And the box is in limiting equilibrium. Limiting equilibrium means friction force is equal to mu times R. Correct?
Yes.
And we have to find the value of X. So let's start with first one here. So let us put all the forces first. So this we have to take it as Y axis. This we have to take it as X axis. Okay.
Yes.
And all the forces we have to take. This force is normal reaction. And what other forces will act here? Weight of the box will act downwards. Weight is 3 kg, so 3g. Correct?
Yes.
Then which other force? This force now. What is this? Friction force, right?
Yes.
The box is moving upwards or downwards? The next question. He is about to move up the plane. The box is trying to move upper side. So friction will be opposite to upper motion, right?
Yes.
And this friction will be mu times R. So we have taken all the forces. What about angles? This angle will be 40 degrees. And this angle here will also be 40 degrees. Okay, so let's take Y components first. So R is acting upwards. Then component of 3g. Component of 3g will be 3g cos 40 degrees, and it will act in negative y direction, so negative. Then again x, component of x is x sine 40 degrees, and this component is acting downwards, so minus, and the other force is x direction, so no components of that. So r value will be unknown, right? So let's write equation of r. R is 3g cos 40 minus x sine 40, minus will go to the other side, becomes plus, right? So this, let us call it as equation 1. Next, let us take sigma x, that is x components of forces. So so let's take x component. X cos 40 will be the component, it's acting in positive x direction. Then 3g sine 40, this is acting opposite to x direction, so minus, and then friction is acting opposite to x direction, so minus for friction also. So coming here, we need to substitute the value of r here. Okay, substitute the value of r here. So what do we get? So this total should be 0, of course. So x is unknown, x cos 40 minus 3g sine 40 minus mu value is given 0.3 into, in place of r substitute this whole equation, so 3g cos 40 plus x sine 40. Okay, so the equation is a little large. Okay, so total should be 0. So keep x values on one side and send the other terms to the other side. So x cos 40 will stay here, then this side x is there, so we will get minus 0.3 sine 40. So this will stay on the right side. Send the constant terms to this side, so we get 3g sine 40. We'll need some space here. Let's move this side. So 3g sine 40 has become positive on the left side. Then 0.3 3g cos 40, this will also become positive this side, right?
Yes.
So x will be this total divided by this total. Okay.
Yes.
So let's feed it in the formula directly. So first numerator 3 into 9.81 into sine 40 plus 0.3 into 3 into 9.81 into cos 40, then divided by these terms, right? So cos 40 minus 0.3 into sine 40. How much are we getting? 44.8.
44.8.
This is in newtons. So this is the force required to start causing the motion on right side, upper side. Next, he is also asking B bit. He is asking, so this is our A bit. B bit is asking find the normal reaction. So for normal reaction, we should take this value, feed it back here. Take a different color. So take this value, feed it back here. Okay. So R equals, let's find it. R equals 3 into 9.81 into cos 40 and plus x value is 44.80 into sine 40. So we are getting 51.34 newtons. So this is the answer to B bit. Okay, any doubts here?
No, sir.
Okay, so let's go for the 10th problem next. Okay, so a small child sitting on a sledge rests in equilibrium on an inclined slope. The sledge is held by a rope which lies along the slope and is under tension. Okay, so we have a rope here which is pulling the sledge backwards. Okay, and it is under tension. The sledge is on the point of slipping down the plane. Okay, that
Yes.
means it is trying to move down the plane. So where will the friction act? Friction will act on the back side, right? This will be the normal reaction. Friction will act backside, and it is on the point of slipping. That means this friction force will be mu times r. Modeling the child and sledge as a particle and the rope as a light inextensible string, calculate the tension in the rope. So we are supposed to find the tension of the string. Given that the combined mass of child and sledge is 22 kg, so downward mass 22 kg, so 22 times g, 22 times g is the combined weight of both these objects, the child and the sledge. Coefficient of friction is given 0.125, that's given over here, and the slope is a plane inclined at 35 degrees to the horizontal. Okay, so these are the values given to us. Ready?
Yes.
So this, let me take a different color. This is our y-axis, this is our x-axis. Okay, so x-axis and y-axis. So this angle will be 35 degrees. Okay,
Yes.
that angle will be 35 degrees. Remaining are either parallel to the slope or perpendicular to it. So let us start. First, let us go with x components, or let's go with y components first, because we are supposed to find reaction first. So r is acting in positive y direction, so positive. Then 22g component is cos 35. This one is acting in negative y direction, so that is negative. So this total should be 0 because all other forces are parallel to x-axis. So r, we will get it as 22g cos 35. So let's find this. 22 into g is 9.81 into cos 35. So we're getting 176.79 in newtons. So this is the value of r. Then we have to take sigma x, all the x components of the forces. Let's take them. So mu into r, mu is given 0.125, so 0.125 times r. This is in positive x direction. Tension is also in positive x direction. Component of 22g will act opposite to x direction, so minus 22g, and component is sine of 35. So 1, 2, 3, these three forces we have taken, so total should be 0. So here we know the value of r, so substitute the value of r. T will be the only unknown, so if T equals 0.125, this becomes negative on the other side, into 176.79. This one becomes positive, 22g sine 35. So what do we get? So minus 0.125 into 176.79 plus 22 into 9.81 into sine 35. So 101.69, correct?
Yes.
So this is the value of tension in the rope. Okay,
Yes.
so that's it. Next, 11th one. So let's take the next one. Ready? So a box of mass 0.5 kg is placed on a plane which is inclined at an angle of 40 degrees and the tension is acting at 20 degrees. Okay,
Yes.
so what are the forces? The first downward force, weight is how much? 0.5. So 0.5 g will be the weight acting downwards. Coefficient of friction is 1 by 5. That means mu value is given as 1 by 5. The box is kept in equilibrium by light string, which is like this. The string makes an angle of 20 degrees as shown. Box is in limiting friction, limiting equilibrium, and may be modeled as a particle. String is T. So in which direction is the box trying to slip? Is it trying to slip downwards or upwards? I think upwards is not possible because he's telling it is held in place. Okay,
Yes.
held in place means it is trying to slide downwards. So this is the direction of motion or tending motion. So friction has to be opposite to it. And because
Yes.
it is in limiting equilibrium, this has to be mu times r. And r will be acting normal to the plane, correct?
Yes.
So this is r. Once again, we have to take x and y directions. X will be this direction, y will be this direction. Okay, so y direction and x direction. So this angle will be how much? This angle will be 40 degrees. Okay,
Yes.
this angle is given from x direction and all other forces are either parallel or perpendicular to x and y axis. Might be about to move up or down. Okay, so here in the hint, if you see, he has given both. Okay,
Yes.
and in the question he is asking us to find the possible ranges of t. So all the possible values of t we need to find. Okay, so minimum value
Yes.
of t, if we have minimum value of t, it will slide downwards, right?
Yes.
If you take t minimum, it will slide downwards. So friction will be upwards. Friction will be upwards. And if
Yes.
t is maximum, then it will slide upwards. It will try to slide upwards and friction will be downwards. Okay,
Yes.
so this is what we need to understand. So first let us take sliding downwards, so friction will be upwards. Okay, so let's take this as a bit, this as b bit. So let me change the color of this. Okay,
Yes.
so first let's go with a bit. It's sliding downwards, so the friction is upwards and tension is minimum. So first sigma y, the sigma y, what are the forces? R is acting upwards. Component of 0.5 g, that is cos, this is acting opposite to y, negative y direction. It's acting in negative y direction, so negative. Tension is going upwards. We want y component, which will be t sine 40, sorry, t sine 20, and it will be acting in positive y direction, so positive. And the remaining force, that is friction, is parallel to x-axis. It won't have any y component. So let's find the equation for r. That will be 0.5 g cos 40. This becomes minus t sine 20. So here tension is minimum, so let's call tension as T1, and tension here, let's call it as T2. Okay, let's take it tension T2. Okay,
Yes.
so tension T1 we have taken. This is equation number 1. Next, let us go with sigma x. All the x components we need to take. So x components is mu times r in positive x direction, then 0.5 g into sine 40. This is in negative x direction, so minus. Then T1 cos 20. This is in positive x direction, so plus. And r is perpendicular to x-axis, so no component. So this total is 0. Substitute the value of r here. So mu value is 1 by 5. R equation substitute 0.5 g cos 40 minus T1 sine 20, bracket close, then remaining equation as it is. Okay, so remaining equation as it is. Okay, remaining equation as it is. So this total is equal to 0. So now we just solve it. So t terms, keep it on one side. What do we get? T terms, we get minus 1 by 5 sine 40, sine 20. From this we get this much, and from this we get plus cos 20. Correct?
Yes.
Send all the constant terms to the other side. We get 0.5 g into sine 40, and if you open the brackets, we will get 1 by 5. Open the brackets, we get it positive on the left side, the right side it becomes negative, so 1 by 5 times 0.5 g cos 40. Correct?
Yes.
So these are our equations. So T1 we need to find. So T1 will be this whole right side quantity divided by left side quantity. So let's go ahead and do this over here. So first is this component. So let's take A by B format. 0.5 into 9.81 into sine 40 minus 1 by 5, that is 0.2 into 0.5 into 9.81 into cos 40, and in the denominator we should have this quantity. So minus 1 by 5 is 0.2 into sine 20 plus cos 20, that is 2.756 in newtons. Okay, so T1 is the
Yes.
minimum value of T. T1 is the minimum value of T. Next, we have to take B bit. B bit, what will happen in B bit? Sliding upwards. It will try to slide upwards. Okay, so the direction of friction will change here. Direction of friction will change here. So let me take the same diagram, same free body diagram. Okay, same free body diagram, but here what will happen? Friction direction will be opposite. Okay,
Yes.
friction direction will change. Once again we need to solve the same equations. Okay,
Yes.
so our equation we will again get the same. Our equation we will again get the same. What is our equation? 0.5 g into cos 40 minus what is it, minus t1 sin 20. So same equation. Okay,
Yes.
because the change in direction is happening in x direction, so y components are not affected. Then coming to x component, sigma x, if you do, again you will get a big equation. Again you will get a big equation. The only change that will happen, what change will happen here? This value, instead of positive,
Yes.
it will be negative, correct?
Yes.
So this whole term this whole term becomes negative. So let me take the same equation directly. Take the same equation directly. Okay, so there is not enough space here. Oh, what happened? So let me keep it here. Okay,
Okay.
I'll keep it here. The difference is that we will get is negative, right? So when you take that negative, the t1 terms will become positive. So this term becomes positive, that is 1 by 5 sine 20, and this will be positive again. And on the right side, this becomes positive, and this term is negative on the left side. On the right side it becomes positive, correct?
Yes.
So 0.5 g into cos 40. Okay, so T2, this will be T2. T2 is maximum tension, right? So T2 tension will be this right side term divided by this term. Okay, so let's again find it. So right side term, everything is positive, so this minus becomes plus, and denominator term also everything is positive, so this negative will go away. Okay,
Yes.
so we are getting 3.87. Huh? A very small difference is there here. Okay, so
Yes.
minimum value is 2.756, maximum value is this much. So the tension will always remain within these limits. Okay, so tension will
Yes.
be greater than 2.756, but it will be less than 3.87. So this is our answer.
Yes.
Okay, so 11th problem solved. 12th one next. Okay, next box of 1 kg. So is it the same? No, tension is known here, right?
Yes.
So downward force is 1 kg. 1 kg means just G. 1 into G is G. Then it is inclined at 40 degrees. Box is kept in equilibrium. Point of moving up the plane. So box is trying to move upwards. So motion is upwards. Okay. So
Yes.
tension will be in what direction? Tension will be in downward direction, right?
Yes.
Then normal reaction will be like this. Any other force acting? Tension is 10. Yeah, that's it. Mu. So find mu, he is telling. You have to find the value of mu. Ready?
Yes.
So this is our x direction. This is our y direction, right? So y direction, x direction. So sigma y. So what is this for value? This angle is 40 degrees. Correct? So that angle is 40 degrees. Then take all the vertical components. Reaction will also be upwards, and because it is in limiting equilibrium, here it is telling limiting equilibrium, so this friction will be mu times r. So y components, r is positive because it is acting in positive x direction, it is positive. Then minus g into cos 40, this will act downwards. Component of 10 newtons will act upward direction, so plus, and the component is 10 times sine 20. So others are parallel to x, so no components. Write equation of r, that is g cos 40 plus 10 sine 20. So all values are known here, we can find it, calculate it. So g is 9.81 cos 40 plus 10 sine 20. So 10.94
Yes.
newtons. Then x components, take all the x components. So let's do that here. Okay. Okay. X components. So first let us take 10 cos 20. It is in positive x direction. So plus g into sine 40. This will be in negative x direction. So minus. Then mu r is also in negative x direction. So minus. Total should be 0. R value is known. Let us substitute it. Mu is the only unknown, so we have to find it. So 10 cos 20 minus 9.81 sine 40. This term, take it to the other side, divided by r will give us value of mu. R value we know, we can substitute from here. Substitute. So mu value is how much? This value 10 cos 20 minus 9.81 sine 40. Did you get it? Correct? Hello?
Yes.
Okay. So 12th one over, 13th one. Let's take it here. So box of mass 2 kg rests in limiting equilibrium on a rough plane at angle theta. So diagram is not given for this. Yeah, diagram is not given. So we have to build the diagram. Fine. So 2
Yes.
kg is resting on a limiting equilibrium on a rough plane that is inclined at theta. So let me take this. It will be inclined, right?
Yes.
So let me take the box, and then we need to incline this. Okay. So this is at an inclination, right?
Yes.
So inclination, what is the angle? Angle of inclination is theta, and
Yes.
tan theta he has given us. Tan theta is 3/4. So we can find sine theta. 3/4 means this will be 5. So sine of theta will be 3/5. Cos of theta will be 4/5. Correct?
Yes.
Now a horizontal force P acting into the plane is applied to the box. Given that box remains in equilibrium, find the maximum possible value of P. Okay. So there is a horizontal force acting, right? So let's say horizontal force like this is acting, okay?
Yes.
And that keeps the box in equilibrium, and he's asking maximum value of P. So if P value is maximum, in which direction will it move? Upwards or downwards? Yes, ma'am? If P value is maximum, motion will happen upwards, right? Motion will happen in
Upwards.
upward direction. So friction will act in downward direction. Friction, friction should act in downward direction, right?
Yes.
Normal reaction will act always perpendicular. Okay, so this is normal
Yes.
reaction, and because he is telling it is given that box remains in equilibrium. Equilibrium means, and the value of P is max. Value of P is max. That means motion will be tending on the upper side. This will be in equilibrium. What is that? Which equilibrium? Balanced equilibrium, right? Limiting equilibrium. This will be in limiting equilibrium. Then downward force, that is the weight. Weight is 2 kg. So 2 kg means 2g is the weight.
Yes.
And anything else? That's it. Now we have to take our x and y axis. This, let's take it as x axis. This, let's take it as y axis. Okay.
Yes.
So x axis and y axis, and this angle will be same as theta. Same way this angle here will be same as theta. So this is our diagram, and we have to start solving it. Ready?
Yes.
So let us start with sigma y components. R is acting in positive y direction. 2g cos theta is acting in negative y direction, and P sine theta is also acting in negative y direction, so minus. Friction is parallel to x axis, so it doesn't have any effect in y direction. Total should be 0. R equals 2g cos theta. Cos theta is how much, ma? Cos theta substitute here, sine theta substitute here.
Yes.
Yeah. So cos theta is 4/5 minus, this minus becomes plus on the other side. So P sine theta is 3/5. So yeah, this is the equation for R. Next, let us go with sigma x. Take all the x components one by one. So we have p cos theta acting in positive x direction, and we have 2g sine theta acting in negative x direction. Then mu r will also be in negative x direction. R is in y direction, so it won't have any x components. So total should be 0 because it is in equilibrium. Now substitute the equation of R here. Okay, so we get
Yes.
p cos theta. Cos theta is 4 by 5 minus 2g into sine theta. Sine theta is 3 by 5 minus mu. Mu is given. Mu is given or not given?
Mu is not given.
First find the coefficient. So coefficient of friction also needs to be found. Let us keep it as it is. Okay, so because this mu, keep it as it is. R, substitute this. So 2g into 4 by 5 plus p times 3 by 5. Correct?
Yes.
This total should also be 0. So here, how many unknowns are there? Lots of unknowns. Mu is not known, p is also not known, R is also not known. So 3 unknowns need to be found here. We are getting only 2 equations and we have to find 3 unknowns. How are we supposed to find that? We won't be able to find them. 3 unknowns cannot be solved by 2 equations, and we get only 2 equations, x and y. How on earth are we supposed to find? Some more information needs to be given here. Without that information, with that information missing, I don't think we can find it. Hello?
Yes.
Some information is missing here.
Yes.
Even though in the hint he is telling first find the coefficient of friction. But how to find coefficient of friction? There is no information given. Some additional information has to be given. Only then we can find coefficient of friction. Rest in limiting equilibrium. Oh. Okay. So within the first sentence he is giving limiting equilibrium on a rough plane inclined at theta over the horizontal, where theta is that horizontal force acting into the plane of lateral blocks. Okay, now I got it. So what he's telling is, in the absence of the force P, okay,
Yes.
in the absence of the force P, the object is tending to slide downwards. That's what he's telling. Okay.
Yes.
So if there is no force here, if there is no force here, if there is no force here, let's remove it, then the object is just about to slide downwards. The object is just about to slide downwards. Okay. That means friction will be acting in which direction? Upper direction, no?
Yes, sir.
Friction will be acting in upper direction. So in this position, it is just about to slide downwards. So with this information, we can find coefficient of friction. Okay.
Yes, sir.
So first we need to find sigma y. So r is upwards minus 2g cos theta. This total should be 0. So r equals 2g cos theta. Cos theta is how much? Cos theta is, here we have found 4 by 5.
4 by 5, yes.
So r value is 2 4 is 8, 8g by 5. This is the value of r. Then now if you do sigma x, mu times r is in that direction, minus 2g sine theta is in opposite direction, right? So r value,
Yes.
if we substitute, mu times 8g by 5 equals 2g into sine theta. Sine theta, again we found it 3 by 5. Okay.
Yes.
So now we can find mu. So g and g will cancel, 5 and 5 will cancel, 2 4. So we get 3 by 4. Correct?
Yes, sir.
That will be very high value. We don't usually get 0.75. Have you made any mistake? Check it. It's correct.
Oops.
3 by 4. Yes, that's correct. Okay.
Yes, sir.
So this is the value of mu. So now since we know the value of mu, we can substitute here and we will get the value of p. Okay.
Yes.
So this thing, let me keep it aside. Okay. First we need to find mu. So first this should come at below. That should come up. This should come here. Okay, this will follow that. And here we need to continue. So we need to use the value of mu here. So let's continue here. So p terms, keep it on the other side. 4 by 5 and minus 0.75 into 3 by 5, correct?
Yes.
And on this side we get 2 3s are 6, 6g by 5 from this term, and the other term, this will also be positive. 2 4s are 8, mu times 0.75 times 8g by 5. Okay, so find the value of p.
Yes.
Find the value of p. So p will be this left side term by right side term. Six into 9.81 by 5. Yes, 6 into 9.81 by 5 plus 0.75 into 8 into 9.81 by 5 whole divided by 4 by 5 minus 0.75 into 3 by 5. Okay, we are getting
Yes.
67.27. Okay,
Yes.
this value, if you substitute, you will get value of R. So R equals, substitute P value, so 2 into 9.81 into 4 by 5, that's it now, plus P value 67.27 into 3 by 5, correct? So that's giving us 56.06 newtons. Okay, so these are our
Yes.
answers. Any doubts here? Okay, so shall we stop here? It's already 7.
Okay, sir.
We started at around 4:30, right?
Around 4:45, yes.
4:40. Yeah, it's been more than 2 hours. Let's stop here.
Okay, sir.
We'll continue in next class. Okay?